So what I'll do, I'll create a new project. Let's say a console app in this place. So I'll call it lesson playground. And I will, why is the internet so slow? I don't know. It's on the red at all times. I'll also mute myself on Discord, as I think only Twitch is necessary.
Sounds good.
So we go back here and we paste what we had before. Sure, we don't need this. So we have a program. This is just what we use to run what we have. And we have a getter function, which we don't really need in C#, but we'll talk about that soon. So we create a new person. And when we want to print just his full name, we now say get full name. When we inspect person, we only see a single property that it has, which is get full name. It's not a property, it's a getter method. But we see only that, get full name. If a person can go to VC privately, but can talk publicly, and publicly that can be invoked, we shouldn't expose it, what we don't need to call publicly. So my point with this one, I don't need those three, and I won't ever need those three. And I'm not doing it just in case. I just want to have a limited access to them, because it gives me no extra info, it gives me no extra help. I just want full name. I don't want those. I want to set those and make them read-only. I'll make the intention more clear. So they are read-only now. So I set them once and forget. Get full name is the only place where I will use them. So why do I need private? Why don't I make everything public? Because it adds complexity to someone who will use your code. Maybe you will understand what you wrote, but someone else might not. When you have private stuff, you make it very easy for someone to understand what you have. So we're talking about C# here. And so in C#, instead of this, I would have full name, property, with a getter. Like this. Actually, completely like this. So this would mean that name is get only. So I can move it here. Comment, oops, comment there. And we're good. So now when I call this one, I can say person, full name. And so when I inspect person, and I'm looking for properties only, I'll see a single property. No fields, just one property. And this is as simple as it can get. And this is very simple example. I'm just having four members of a class, right? So if I had, like typically I have many more. And if I expose all of them as public, even though I need them only internally, I would pollute my program quite a bit. And that's why I shouldn't expose what I don't need. Because someone who will use it will have extreme simplicity consuming such class, because I have full name. So Just like you have your room tidied, just like you don't put everything you know on a table in a room, just like the same way you don't put everything public in your classes, because everything has its own place, and if its place is not outside, don't enforce it to be outside. I mean, if its place is just the class itself, just the internals, why should I care about it from the outside? Does this answer a question about why things should be private more than public, more often than public?
Yes, it does clear it up a lot. Thank you.
Okay. So there is a saying about object-oriented programming, which means, I'll type it out. OP is poo. And what the hell does that mean? Yeah, the delay is there, but don't. It's just to be accepted with my internet. So I hope you can bear with it. Anyways, there is a saying OP is poo, and what the hell does that mean? POO is programming for others. That's the acronym. So programming for others. That's what POO is. And so with encapsulation, we can achieve that. We hide what we don't need and expose just what we need. And we don't think about future that much. I mean, we try to design our classes by exposing just enough information, because every bit of information extra that we expose will add complexity to it. We don't want that, and so we don't do that. Right. So encapsulation is tricky because sometimes you will need something that you already made private or something like that. And so you need to get a sense for what needs to be public and what needs to be private. And then you have protected as well. So who could tell me the difference between private and protected?
Protected can be like change only from the classes that inherit the one that has.
Yes, that's true. So when do you so protected means that classes which inherit, protected means that it can be inherited. Private won't be inherited. Public will be inherited. Protected will be inherited as well, but it won't be exposed to the public. So it will be just like private, except that it can be inherited. So when do we need something to be protected then? How do we make a choice, a design choice that something should be protected? Or do we first make inheritance and then make it protected? Like, how can we measure that? How can we decide? What do you guys think?
Maybe we have protected like only when the class that inherits it has to use it.
Well, the main thing about inheritance, the main thing about protected is design for your inheritance. So when we talk about person, for example, those are things that might really be needed for a person outside. So they could, if I had more classes like person child classes, I might make those protected. Might doesn't mean that I will, but I might. It's a design choice. But for something that you are sure you will consume, that you would consume on a child, you would make it protected. So for a person, what could that be? Let's say a person privately, what does a person privately do? Think bad thoughts. Let's say a person thinks bad thoughts privately. No one calls that, but he does it anyways. And that's something that child classes could do as well. So my design would be that I make this protected because it's very likely to be called from child class as well, used within a child class. Though a design says that we don't do this that often. We avoid to do this. We don't want to use parent and child. And so I will go on with... so do you have any questions about encapsulation? Any more questions about encapsulation? Okay.
None.
Right. So that's the most basic principle. And in general, if we don't need it, we make it private. If we need it from outside, we make it public. If we know what what we are doing, we can design and plan in the future and make it protected. If we made a class which inherits this one, like this one, is a person and it takes those. Why is there no autocomplete? So we could do something like think outside of work, live life, let's say, the way policeman lives life, think bad thoughts. He thinks bad thoughts sometime in his life. So basically, something that is a person can use something that a person exposed as protected. That's just the illustration. Might not be a good example, but an example nevertheless of a use case. So let's move on. What I did here is inheritance. And inheritance is a way to say, so who could say what inheritance is? I would appreciate your own description, and then I will add my own.
Money.
Money. Okay.
Right.
So, anyone? Inheritance? Why do we need inheritance? What is inheritance?
It's like reusability of the code, maybe. It's like when we have already something in some class, we can inherit it. And
Yes, essentially yes. Now I will talk about what is inheritance and why we don't preferably use it. Which is a shocker because inheritance is one of the pillars of object-oriented programming. So, first pillar was encapsulation and now second pillar inheritance. What is inheritance? It is, I'll write like this, it's an is a relation like this between a parent and a child. And why do we need it? Because generalization. And another point is code reuse. So who could explain what does generalization mean? Here I have police officer and a person. I'll make this a bit more talk. So when someone talks, I will say that this person says something. So what is generalization? Please say.
I'm not sure.
So generalization is just saying that all police officers are people. So you generalize police officers as person. Or I could go on and say that police officer is just an abstraction of somebody who do police officer work. And this will be abstract. So generalization in the most basic sense means that whatever person could do, the same can police officer do. So whatever parent class could do, the same can a child class do. So if a person class could talk, then a police officer class will also be able to talk. Well, at the same time, do what protected stuff did. So it does this thing, more like this thing, because I inherited it and it was public. So ability to do the same as
So you can do everything a police officer.
Yes, that's true. To do and be the same as parent. And code we use, we have access to whatever the parent had. So in here we can say talk from this one because it comes from person. So let's move on a bit, a step. So let's make an example first. I can create a person in two ways. And there will be two same people. So person one will be just a person. And I already have it. So I'll just say person one. And person two will be a police officer. And I will pass names here. Matt, Tim, also Jenkins. Now, here's the thing. The class that I just created is abstract. Here you see police officer is abstract class. And I made a choice of an abstract class for police officer because I thought that police officers don't exist in general. They need to be specific. Like they need more specification to exist. So common police, more like road police officer, traffic police officer, will inherit police officer. Class, I forgot. And well, I should just do the same constructor again. Let me and give me the constructor. So traffic police officer does work in its own way. We don't know how police officer does his work because it comes as an abstract. And I didn't notice if you're asking questions, so I'll move back to here. I didn't notice if you're asking questions, so I'll oops. So here. So you can ask questions here. I will notice now in the chat. Okay. So console, right line.
Where?
In the chat, if you want to ask question in the chat, if I see it, I'll reply. Or you can ask question on voice. I don't mind. Either way is fine. I just opened the chat, so. So do police work. Catching.
What that override?
I'll explain soon. Catching, speeding up cars. So here you see we have a method. Public, abstract, void. Do police work. And this means that, so I can write abstract because my class
So
is
that's a
abstract.
method without a body.
Yes, that's a method. Abstract means a method without a body. And this means that I have a method which will be implemented somewhere else. Abstract class means that this class is incomplete. It has some implementation, and this is the implementation it has. Live life is implementation of a part of this method. And abstract means that I will need to implement this somewhere else. So a method which is defined but not implemented. What does that mean also? That means that all police officers do police work. And I will define how it's done somewhere else. So a specific officer implements the do police work method. It might not implement it, yes?
Abstract classes and abstract methods can be used like templates.
Yes, exactly. They can be used as templates. But we will move on and introduce one more thing soon. So with abstract class is very well said. It's a template basically. It's a mix of a template and implementation. You know some, you don't know some. So with abstract class, you can model that. So what I don't know about police officer in general, how it does police work. I know that.
How does an abstract class differentiate from an
interface? Interface has no implementation. Abstract class has some implementation, and that's the difference. And I will
So it's like an interface. There's no body at all.
Yep. Interfaces cannot have something like this, a mix of both. Abstract class can. At all? Yes, at all. In C#, 7. In C#, the newest version, you can have interfaces with implementation, with default implementation.
Some interfaces, they might be able to define a default method.
Yes, but that's the newest C#, and I am against that. And that's not in any other language that I know of. And I am against that. I wouldn't recommend that. At least in general, I wouldn't recommend using that. Because when you have an interface, you expect that something will implement it.
Why are you against it? I mean, even Java also has.
But that's not proper. I think that's not a good thing to have. Because it's against the conventions, against the typical definition of interface. You shouldn't typically...
Just for the record, I
Yes?
hate this 5-second.
Yes, I know that you can do this, but I'm not saying that you should be doing this. I'm saying that you shouldn't be doing this. Because it's not clean, in my opinion, at all. Interfaces are supposed to be implemented. They're not supposed to contain implementation. Because otherwise you're saying, well, you can't do this, but this is a very new thing and it's not a very good thing in my opinion. Because it breaks your understanding of what an interface is all about. Interface is a contract. It's not implementation. The whole point of an interface is to define what a class could do. Just define what it can do without saying how. So with interface, you can achieve that. And be right back 1 minute. And ask questions if it's not clear about interface versus abstract class. And I'll explain soon.
Okay.
I'm back. What we should use, interface or abstract classes? Okay, let me get back to interfaces. You said you can have interface with default implementation. Yes, you can. With the newest versions of languages, you can. In some languages, in most languages you cannot. So, default implementation interface might come in handy when you have basically classes which share that implementation, which have common implementation by default. But that's not the case. That shouldn't be like a typical default case. By default, you should define it per implementation. You shouldn't use that one. Yes. So, let me go on with abstract class and then we'll move on to interface so I can compare the two, because now I don't have interface here, yet I'm talking about it. So we have an abstract class, and here we have basically partially implemented class. That's our abstract class. And here we have an implementation of the abstract class police officer and traffic police officer. Let's make one more class to make this example more complete. So instead of traffic police officer, I'll say, so you have traffic, and then you have what other kinds? I don't know police officer names, types. Let's say chief police officer. Homicide is a good one. We can have homicide police officer. Homicide police officer. So do police work? Inspecting crime scene. And this one, commanding other police officers. So we have 3 implementations of a generic police officer, and those 3 implementations do police work differently. So let's demonstrate that. Traffic police officer, and those will be police officers. Police officer 1. Two and 3. And you have traffic, homicide, and the last one is chief. John, Billy, they're all from the same Jenkins family. Christy, Maria, like this. So you have 3 officers, and this illustrates inheritance. You had a base officer, and you inherited at least full name from the person class, and you inherited a method that you need to implement from the base police officer class. So here you have this, and this is inheritance. Inheritance is quite straightforward. Code reuse and generalization. Generalization meaning that traffic police officer is a police officer. Homicide police officer is a police officer as well, and so on. I don't have to provide this type. I could write var, but this is for clarity's sake, that they're all officers here are police officers. None of them know about the specific type they were created as. They're all police officers. And so now I'll put them all in the same array. So I will, maybe police officers will be a better name. Police officers. I will get to the point. Police officers, I'll get to the point when we come to interfaces. And I'll give a different example where inheritance is much worse than an alternative. So police officers, new array, and I put them there. Officer 2 and officer 3. Right, and I say for each var officer in officers in police officers, they will do police work. So if I run this now, I should see that each of them, you know, they do police officer work. Catching, speeding up cars, inspecting crime scene, commanding other police officers. So you see that each, even though they were all police officers, they each did what a specific police officer did. And this is polymorphism. Polymorphism meaning that police officer can have 3 forms. It can be a traffic, homicide, or chief police officer. And based on the form they were created as, they will do their thing in their own way. So polymorphism. In black box, we know that each police officer will do police work. That's black box. And we don't care how a specific officer does his work. We just know that they can do that work. So that's polymorphism. Ask a question about polymorphism if you want. If you have, do you have any questions about polymorphism? Because I will continue on. Same method, do police work differently.
Can I take the code beyond?
Sorry, I couldn't pick up what you said. Do you need
Can you scroll a little bit higher?
higher? Yes. Do you need?
I have a question about polymorphism. It's
Yes. Go on. Sorry.
We're using
it's
like
in
the
the
list
chat.
offers as a type.
I'll answer the question in the chat then. Do you need inheritance for polymorphism? Yes. Inheritance, I mean, polymorphism can be achieved in two ways, either through inheritance or through implementing interfaces. So now let's show an example of implementing interfaces. And how can polymorphism be achieved through an interface? So let's create an interface. I'll rename this method from talk to say. Actually, talk is fine. So I'll create an interface called iTalker. So iTalker can talk. And a person can talk. A person can talk, and here a person implements how it can talk. So with this method, person implements this contract. Yes, police officer is a type. It's not a generic type. Generic is a different thing. Generic would mean that I put something here, but I don't. So it's just an abstraction of an officer. Instead of generic, you should say just an abstraction. So back to talker. iTalker is a contract. So person can talk. And this is how a person talks. This method defines how a person can talk. At the same time, I can say cow is also a talker. And the way cow talks, cow says moo. Basically, prefixes, doesn't matter what you pass, let's say, it says moo anyways, because it's not a very smart animal. Or maybe let's make it more interesting. Message will be replace, how should I say, everything? I don't know. Okay, I know. So we get message length. Just do a for each, I guess. Let's say cow moves by replacing all that you put in a message with an M and long moo. So for each more like for int var damn it, var e 0 is less than length and e plus plus we say that that cow message is M and a long moo. So that's what cow says when it wants to say something. We just implemented that. And the thing about interface, what does a cow and a person have in common? Who can say what does a cow and a person have in common?
They're alive.
They're alive, but in this sense, they can both make a sound. They can both talk. Well, cow doesn't really talk, but it makes sounds. And my interpretation of cow talking is just mooing. So two unrelated things unified by an interface. If so, you said a cow is alive, and we could define. We could define how something, be alive. So if something is alive, they can be damaged, I guess. No, not really. Many objects can be damaged. So if they're alive, well, they can breathe. And with breathe, this is a good case for a default implementation of an interface. iLife, let's make it better then. iLife will have a property HP. So the thing is, here we have a property which is common between them, but there's no way I can inherit it. There's no multi-inheritance in most languages, and even if there is, it's a mess. So with this, I can say that both a cow and a person has hit points. They can work with hit points. You cannot do multiple inheritance with C#. Nope. And it's not a bad thing that you cannot. Here. Okay, so here you have HP for both of them. And the thing is, if I create yes, but inheritance for interfaces is not inheritance, it's just implementing. Okay, so we have a cow and we have well, we already created police officers. So now again, what does a cow, person, and police officer have in common? Who can say? Yeah, talk, life. So we can say something like this. Livable. And we store them all here. Cow, officer 1, and person. Why? Okay, good. And we can do again a for each. And here we can do something like damage them. Livables. And we take one. Let's make a method actually. So now that we know that something that is livable can be damaged, we can damage them. So if I pass a livable, I life, this array is iLife. And here I say I create array with 3 elements. Cow, officer, and person. They all have HP because they all implement iLife interface. And that's why I can all store them in the same array. So I can say I can damage this one by the HP I passed in the method, and I can say this. Before HP and after. Those who don't know what the $sign means, it's string interpolation. It enables me to write in curly braces something without concatenating strings. So if I run this now, well, I still need to damage livable. So I damage each. Yeah. So I damage each by 15. Livables. And if I run, you will see, you know, before, well, I created each with a default value of HP 0. I should have fixed that, but it doesn't matter, it's just an example. So I damage each by 15, and doesn't matter, a cow, officer, or person, they all behave the same. They got their HP reduced, and I could access it. Because in life, I had the property defined. So why do we need interfaces? Why do we need interfaces when we have inheritance in abstract class? Is that still not clear? Okay, so with inheritance, look what I wrote. I wrote that, where is it? That inheritance forms an is a relation. So police officer is a person. Traffic police officer is an officer too. So we have a generalization of something that is another entity, and we achieve code reuse. But with interfaces, we said that we have something that can talk. We said something that we have something that can live. and cow and person are unrelated. They are not generalization of one another. So with interfaces, we can unite something that is not the same through similar behavior. So with interfaces, we generalize behavior and group classes through common behavior. And interfaces are exactly that, common functionality of unrelated entities. If entities are unrelated, yet they share the same behavior, absolutely different from one another, we can still unify them by generalizing that behavior, by abstracting that behavior away through an interface. So if something needs HP, but nothing else, we can provide the HP through an interface like we did. If we can talk, but we don't share anything else, and the implementation of talking is different, we can provide an interface. An interface should be the most common way of abstracting stuff away. So interface. Classes which are unrelated in any other way than their behavior, which is shared by definition, can be unified by implementing the same interface. So if I didn't use an interface here, I wouldn't be able to damage them all. I would need to say I damage specifically a cow, I damage specifically an officer, I damage specifically a person. Well, maybe officer and person I don't need to because it's inheritance. But a cow I would need to. So I wouldn't be able to treat them within a loop, unified way. I would be blocked from doing so. That's why I need interfaces. So interfaces should be the most common way to reuse behavior. Not to reuse behavior, but to unify different classes and expose their behavior. Yeah. So that's why we need an interface. It's a contract and nothing else. Don't treat an interface as an implementation. Yes, someone said you can. Behavior means talk, basically a function. A method, a function. Behavior is a function. Property is also a function for setting getting. Yes, methods. Methods. Function, method, behavior, method. Same thing. So you have interfaces. And also other guys, please ask a question if you're not sure. If you still don't understand, ask a question and I'll try to explain. If I don't see questions, I presume either it's not clear at all or everything's clear. So you have an interface which is for unifying stuff. For unifying classes which are different. What is the difference between implementation and behavior? So this is behavior, which is unimplemented, but it's declared. Here I declare, here I define that iLife has such interface. So iLife's behavior is to get or set hit points. This is definition of behavior. And here when I go to a cow, I see how such behavior is implemented. For iLife, it's nothing special, just default getter and setter. For talker, it's this, talk method. So this is implementation. And this is definition of what needs to be implemented. This is this is declaration, definition, and this is implementation of that. Now, let's go back and try to understand what an abstract class is. Again, abstract class versus interface. When to use which? So, abstract class is basically a class plus interface. Why am I saying so? Because we have behavior which is just like a class, defined and implemented. And then we have behavior which is just like an interface, declared but not implemented. Exactly, it's class which is partially implemented. So interface is not implemented at all, class is implemented completely, and so abstract class is the middle point in between those two. Yep. So abstract class is powerful, but it comes with the same problems as inheritance. So now let's go back to the point. Why is inheritance hated? What's wrong with inheritance? You know, when you are using something, you keep creating dependencies. And in programming, we don't want to have dependencies. I mean, we are inevitably creating dependencies, but we want to have as little dependencies as possible. So let's consider class talker, a person class. A person class has no dependencies. It's just a person, and we don't see a reference to any other class. Now, if you look at the police officer class, it has a dependency on a person. So inheritance creates a dependency on a parent class. Now, if we look at one more class down, we have traffic police officer. Traffic police officer now has a dependency on police officer, and police officer has a dependency on a person. So that's already 3 dependencies that we create for a traffic police officer. That's no good. So what are the rules for inheritance? Here are some rules for clean inheritance. Well, why are dependencies bad? Dependencies are bad because it's harder to maintain code which is coupled. Because if a change happens, you will have time to move away things. You will have time to change things. Hard time. Maybe something changes, something does not. Consider the following. A police officer does not do police work. A police officer suddenly needs let's see. Let me come up with an example that would be a problem. All right. Let's say a person okay, I will go to police officer. Oh, what's that sound? Okay. God, what's that sound? I don't know. Okay. So a police officer, let's say something changes, something is about to change. A police officer does police officer work. Like this. I should go to police officer. He goes here and he does something that other police officers won't do, but exposes. Okay. So every police officer can shoot person, right? So I will show first example of bad inheritance. Shooting person. Okay. Every police officer can shoot something. Every police officer can drive a car. Right? Let's say. Every police officer can do something else. Let's do one more thing. What else can a police officer do? Patrol area. Now consider the following. Some police officers don't have a gun and they use a taser weapon. Others use, a baton to beat someone up. They don't have a gun. So shooting, shooting makes no sense. So consider the following. Homicide is fine. Chief is fine. Let's create patrol police officer, right? Patrol police officer is a police officer, and the way he does his work is it just patrols area, right? Now here's the thing. If I call patrol from chief police officer doesn't patrol an area. So his patrol would look like this. Where is it? Patrol. Virtual. I'll make this virtual. So his patrol makes no sense. Actually, I won't make this virtual. Let's not make this virtual. What's the problem? Chief police officer does not patrol, but police officer patrols. So here I define behavior which is not meaningful and which is different, fake, not good for other types of officers. Let's continue. Fix formatting, implement. Okay, so this is good, but patrol police officer, let's say, doesn't drive a car, and yet I defined a method that it does here. So by saying this, I say that absolutely all police officers know how to patrol an area, drive, shoot, and do police work and live life. But that's not really true. They will all do police work. Not all of them will use shooting. Not all of them will do driving. Not all of them will do patrolling. And inheritance causes problems like this. When you inherit too many things, you start faking classes. So if I inherit this, I could make it work. I could make this virtual, and let's say here, chief police officer does not patrol. And so I say that he doesn't do that. So when you create dependencies and when your design changes, in this case, I knew in advance that not all police officers patrol area. So with this, I say that all officers patrol area, but suddenly one officer does not. And so I need a mechanism, some way to say that it does not, and then I need to fake it. I expose a method which has no meaning in the context of chief police officer. That's why inheritance is bad, because you might inherit what you don't want, or requirements might change, which breaks the inheritance. And it's quite likely to happen. That's why inheritance is so not attractive to most people. Inheritance might break the relation that we defined here. Is a relation. Yes, chief police officer is a police officer, but all police officers don't have to patrol area. In this case, why do we need virtual keyword? I mean, we can override and throw exception for non-virtual methods as well. Yes and no. So why do we need virtual keyword? Virtual lets us override. We cannot override non-virtual methods. If I wrote like this and scroll down, you see here, cannot override inherited method because it is not marked virtual, abstract, or override. So I cannot. However, I can write this, and this will work. But if I call this method from polymorphism, it won't throw exception. If I call it like this, let's do it. If I go up, livables, and no, not here. If I say here, so we have those three officers, and we say officer patrol area. Look what happens. So patrolling, patrolling, patrolling. Did you notice? Do you notice anything weird? Anything that was not supposed to happen, maybe? If I scroll down here, you see this. Why didn't this throw an exception? It should have. Or should have. No exception because I wrote new. So the only way I can make it throw an exception, new means that it will ignore polymorphism. The only way I can throw an exception for that one is by calling it not as a police officer, but as a specific officer. So if I say this, if I treat police officer as chief police officer, and then from this one I call patrol, it will throw an exception. You see? So all of them patrolled, and then I called it again. So with the new keyword, I basically say that I treat it only from the from non-polymorphic behavior. This method makes sense only from non-polymorphic behavior. And so if I do this instead and have a virtual method instead, here, it means that now I can override it. And it means that I can use polymorphism at the same time. So if I do this, you see that it patrolled only, 2 times, and when chief officer came, it immediately threw an exception. I didn't have to write this now. I could rely on polymorphism. And that's why I need virtual methods, to be able to have polymorphic overridable behavior. Officers which are treated as one, but at the same time overridable. Patrol area is a black box for me, and it could differ. And with virtual, I say that it can differ. But for the same reason, it's not a good thing, because it says that potentially all of my implementations could look like this. There's nothing preventing me from doing this. And this is a very bad practice, and this is why you don't want fat inheritances. Because suddenly, you don't want this, and you don't want this. Because when you call a method, you don't expect it to do nothing or throw an exception for no reason. It should do what it's told. If I call patrol area, I expect something to patrol area. So this is a bad practice and shouldn't be done. That's why inheritance is not good. Because imagine you started the design saying that all police officers are supposed to patrol an area, but then chief police officer does not. And then you eventually make those methods virtual, and then you override the behavior of this one and say it doesn't do anything. Probably you would do this because you don't want your application to crash. You do this, it works, but it's dirty and it's hard to maintain for someone who takes over your code. That's why inheritance needs to fully represent what behavior gets reused, what code gets reused. You don't want to reuse some and then ignore some. You want to fully reuse it. So let's go back and define rules of inheritance. So, number 1 has to form a logical relation. What do I mean by a logical relation? Some people say that if you have a class called a team, and if a team is basically a list of players, they say, hey, I will inherit a list of players. I'll just call it person. I can do this, no problem. But what's the problem with this? Could anyone name a problem with this one? What's wrong here? With team inheriting a list, if team is a list, anyone? So the problem with this one, well, you want to have a list of players. Like, what do you want to do with a team? If I do this, right? Person. So if I do this, and then I say, go up, I say team is new team. What do I want from a team? I want from a team to be able to add players, persons. I have that, right? All the implementation that I want from a team I have by inheriting a list. So I can add officer 1. I can remove officer 1. Voila. I mean, all that I need I get from a list. But what's the problem here? What's the problem? The problem here is that team is not a list of players. It has a list of players. Team does not form and is a relation with a list. Even though it has a list under the hood, that doesn't make a team a list, because even though I can add and remove people from a team, I have a lot more than I want. I don't want to sort. I don't give a shit. I don't want to reverse it. I don't want to remove range. I don't want to find index, find last, for each. I don't want any of it. All I want is to add or remove stuff from a team. Add or remove players. So this doesn't work. So it says, do not inherit semantic relations. Here, by inheriting a list, I inherit semantic relations. Add, like all those methods here is semantics of a list. If I want just add or remove a player, I shouldn't be able to have all other things, because again, encapsulation. We violate encapsulation by inheriting something that is not really our class. That's why we encapsulate a list of person within a team. And by creating a team, we create a list of people. And just like we did, we expose add person method, which adds a person into people list. And we expose remove by index or reference. So let's consider the two following classes. Bad team. Sure, this class is way less code, but now let's consider the complexity. We created a team. Oops. So we created this team, and now we need to work with a good team. What do we see? Add and remove. Basically, two methods that our team offers. Now, let's consider a bad team implementation. What do we see? All kinds of methods. I need just to add and remove a person to a team. Yet I have all those that I don't need. Maybe eventually I will need, but right now I don't. So it adds so much complexity if I inherit what I don't need. So that's where encapsulation and proper inheritance comes in. All right. So that's why we don't inherit a list, because we don't need semantics of list. We want logical relations to inherit that. Now, another rule is that child should not use a parent. Child should be purely additive. This is a rule that often gets violated, and it isn't as much as a problem as as other rules are, but this just makes it a bit harder to maintain. You know, if I go here in this one and now I want to work with it, how do I know what I have? I need to go and inspect this class. So just by inspecting a parent, I will be able to know what I can work with. And this is like a mini global scope. It isn't really global, but it's not in my scope. This is the scope that I should be working with. But with inheritance, it asks me to go deeper. And the more levels of inheritance I have, the deeper down the line I'll go, and the bigger my scope is. This is my scope, and this is the scope I want to work in. So by doing inheritance, I create the scope bigger and bigger. Now consider this. I have a list of people. And how do I know what I can do? Well, I know this is a list, and by saying dot, I can see what the list has. So I know what my immediate friends are, and this is my immediate friend, basically a member which I can call. So I can call people, and by calling people, I know what they do. But here I need to do this and, check what I can, or just call it without knowing what I can call. And it makes it a bit more complex. And if I go more like down here, I already have no idea that I can have a full name as well. And that's fine. I shouldn't even be aware, because I should have extra behavior on top and not a behavior that I use from a parent. Parent should simply have a behavior defined that others use. And that's it. Simple as that. So, child should not use parent. Child should be purely additive. Right? And in a sense, this isn't so bad, because their child doesn't use parent and it's additive. But the problem is that I still have too much. And the third rule. What's the third rule? Additive, logical relation. So here I'll add don't fake logic. Don't override, throw exceptions, so on. That's bad. Has to form logical relation. Child should not use parent. What else? What else? Oh, right. Not more than 2 levels deep. So inheritance creates global scope, mini global scope. Like not really a global scope, but kind of. And deeper down we go, harder it is maintained. And with every complexity, with every inheritance level, we create a responsibility, a dependency. So we don't want that. A change might break everything. It works as long as it works, but it's not change proof and it's not stable. That's why inheritance is not good. And now I wanted to finish this with a perfect example of when inheritance fails, but other thing works very well. So let's go down the bottom and let's create one more class. Let's call it tile. Tile, like as in, under your foot you have a tile. And, right, so we can render a tile. No, what can we do with a tile? Let's say just nothing. Let's say a black box, something that exists in a tile. And then let's say some tiles move. right? And moving tile is a tile, right? That's true. Moving tile is a tile, right? And then what do we have? A moving tile with text. Well, moving tile with text is a moving tile, right? What if we have a tile which doesn't move but has text? Well, tile, text, not test. Is a tile, right? So we have the following. It would work, but let's say we have tile with color is a tile, but then we need to make all combos again. Tile with color with text, tile with color which can move. It breaks it. It breaks it, and it's bad. It's really bad, and it explodes with classes. And here comes a principle. Prefer composition over inheritance. So this is bad. Maybe I'll just make another region. Region, good. Okay, so this is bad. This is horrible. This explodes with classes, and for every combo, we'll need to make a like a combo class. Combo class is really bad. It gives no value and it's hard to maintain. So what's the good solution for it? The good solution for it would be the following. I'll comment. I'll just call prefix all with bad so that I don't mix the names. And now the proper implementation, drums. We have a tile. And now we have a moving tile. So in order for a tile to move, it needs to have a motor. In other words, a component. Now, if a class can have a color, then we need a renderer or something. And one more, we said it can have a text. So how does our tile look like now? So the problem here is that we had inheritance. And imagine that if suddenly we have a change in a moving tile. A change in a moving tile. That this moving tile suddenly nests color within it. Well, we would need to... Well, this class would be broken too. And that's a problem. Very, very fragile classes in this region, for fragile classes. Here we have components. The same components would exist in this one as well. But yeah. But there is a key difference. What is a moving tile? It's a tile it's not a tile. It's tile plus motor. In such sense, it has those two as components. So when I create one, I inject it. And so you see, it's like this. So do tile stuff, do motor stuff in public. Okay, this really requires an example, a better example. I will okay. So if a tile needs to move, it shall, but not by itself, but through a motor. So like this, each other will be implemented. Moving tile with text is a tile text and motor. And the same with others. So I have private components, and through them publicly I expose their behavior. And this might look like code repetition, but it doesn't add much complexity to it. And in fact, it adds lots of flexibility. Because if I want to do something else with this kind of tile, I can by simply adding, removing, changing, or injecting here a different component. It gives me lots of freedom. The freedom which I lacked in this case. Because by inheriting tile, I take all the good and the bad with it. By inheriting this bad moving tile, I do it again. I take all that I want and all that I don't. In the case of a perfect scenario, I might have a working thing and might not see many problems, but I could do it better. And this principle is called prefer composition over inheritance. So I have moving tile, which is a tile with a motor. It's very natural, it's very fluent to think about a tile which moves, to think about it as a tile with a motor, as two components, and one composition class which encapsulates them both. So in this sense, moving tile is a composition of tile and a motor. Moving tile with text is a composition class with tile, text, and a motor. And like this I can compose them, and like this I am very flexible with making changes. How many dependencies? When should you use inheritance? So the design rule says prefer composition over inheritance. So if you think about moving tile, you could figure out that it is made of two components. So if it's so natural to design it with components and reuse components instead of reusing whole classes, you should use it. If it's very convenient to inherit something like with the person class, with things that won't change and we're sure they won't change, then you can. So I should add one more rule to inheritance that I forgot. So use inheritance if you don't break those 4 rules. But think about those 4 rules after you thought about composition. So if you think about composition, so when you design how a moving tile should be done, think of design choices. I could make this, but a lot can change quite fast. And I don't want to depend on a moving tile with text from a moving tile. I don't want to depend on it. Maybe I want something else. It's high chance that it will break. High chance for change. So if stuff is likely to change, be very wary of it. Be scared of it. Be cautious. So those 4 rules are when you should use inheritance. But think about composition first. If you can do it with composition with like this convenient minimal code rewrite, it's not bad, and it's actually preferable and better. You get flexibility and freedom for little cost. Back to dependencies. This class has 1 level deep dependencies as opposed to inheritance, which had nested dependencies which went deeper and deeper and deeper. Here, if something breaks, I just delete this. Let's say motor breaks, I delete motor and replace it with something else. On second thought, if something breaks here, I'm in trouble because I need to go here. What if something broke here? I'm in trouble because I need to go here. So I need to keep going down the rabbit hole until I find the class that I need to actually fix. And that's why inheritance is harder to design, because it's likely to fail, because stuff is likely to change. If you're making a personal project, that's fine. You will be able to use inheritance, and you might even violate those 4 rules without realizing it, because you will do it and forget about it. But real world is not so easy and simple, because requirements change, clients don't know what they want. So it changes, stuff breaks, and you need to fix it. And it's much harder to fix inheritance-based stuff compared to composition-based stuff. So inheritance is not bad. It's just harder to design and prone to fail. That's why the rule prefer composition over inheritance. More than half of use cases should use composition. So back at the start of the lesson, we said that with inheritance, we can reuse the code. Yes, that's true. But with composition, we can reuse the code as well. Here, title and motor carry this behavior. And here, with composition, we can reuse the behavior of a component. So we don't couple it via inheritance. We couple it with composition. We use it. We don't say we are what we use. We say we have what we use. So it's much better. So composition is a way to reuse code. We have private components with public methods, and we expose their public methods through composition public methods. That's it. Do you have questions about composition over inheritance, and is this clear? Does this make sense? in industry, if you look at legacy code or developers who don't know what they're doing, it's quite common. But if you look at very professional industry, like at people, really experienced people who know what they're doing, you will see inheritance as in 20%, 30% of code reuse cases. Mostly like 70, 80% cases will be components based because it's much easier to test and reuse and maintain. Lots of benefits. I'll write some comments here. Region. Do you have any more questions? Homework. I would like to give some homework too. Also, please let me know what you think about the lesson in the comments. I mean, the chat. What you like, what you dislike, because it's about to end, and I will try to come up with homework. So, you actually already did. So, polymorphism was there. I should. Here we see polymorphism. So you treat 3 officers of different types as a generalized officer type. And here you treat officers, people, and cows as something that has life. So here you implemented polymorphism through inheritance. And here you implemented polymorphism through an interface of iLife. And those are the only 2 ways how polymorphism can be achieved, through having a general higher level abstraction which specifics can inherit or implement. And we work with abstraction rather than implementation. And so it's a black box how each works. Those are black box, but we can use them through polymorphism. Yeah. But this topic was mostly about encapsulation. But I went deeper into other topics too. So I don't know. We'll see. I would appreciate that you guys had many questions the next time, the next lesson, next week, so that we have something to prepare, something to work on, something to do things about. Because this is basically pretty much all OP. Black box. So look, here I have an interface, and I know that iTalker can talk by passing a message. Black box means that I know what I pass and I know that it can talk. Black box means that I throw something in it and I get something back. But the key point here is that I don't care how it's done. What's inside the box? I don't know. What's inside the method? I don't know. How does one talk? I don't know. I just know that I can throw a message in and say talk. I will try to fix the delay, and I will try to reduce latency by by maybe optimizing stream settings, maybe changing location. You know it works, you don't know how. Yes. So you know something can talk, you don't know how. How do you know how do things talk? Well, by implementing this. But when you call something that iTalker has, you don't know which implementation will be picked. You just know that some implementation will be picked based on the type we created. So iTalker can talk. How? Well, you need to go deeper, but you don't really care when you call it. That's black box. White box, basically implementation. Black box is just definition. Now, I will give examples. Here I'll just define regions. I don't need here region, but I need here region. Interfaces. Yay, that's good. I'm glad that you understood it, and I really think it's useful because the problem with usual people who teach this concept, they touch the very basics, but not touching subjects that are actually useful, but at the same time not so complex. Right now, what I taught you is a lot, and a lot that is missed and left out, even in universities. In university, they would teach you what a class is, what inheritance is. They would teach you what those things are, but they wouldn't teach you when to use which, when to be careful, what problems can happen. They don't mention those things, and it's horrible. People who... teachers who don't teach about those things in this depth are just setting up for community, for developers who say OP is complex, it's unnecessary complexity, it's definitely not needed, I don't like it because so many abstractions. No, that's not a problem of OP. That's a problem of bad OP, of someone overcomplicating things when they don't have to. Keep it simple, stupid. Simple is better in all cases. And brilliancy is hidden within simplicity, not flexibility. I will quote some of my colleagues. So basically, if you design for simplicity, if you design for flexibility, you get free complexity. If you design for simplicity, you get free flexibility. So it's easy to change and maintain simple code. It's hard to use code which is complex for the reason of flexibility. Even if code is flexible, if it's hard to use it, I won't use it, even if it offers me a lot. So if you expose everything as public, you will have flexibility, that's true. But that creates complexity, which I don't want. I prefer simplicity. You should prefer such thing too. So in the next lessons, we will learn more about this. And I think next lesson will be a bunch of examples which will make the point more clear. Why do we need this OP, and what OP is? We'll cover misconceptions compared with FP. And lesson after that, we will talk about solid. And I'll try to give homework. Okay. So I think, yeah, prefer composition over inheritance. So I divided basically this one big file into regions. I could have done this differently by having namespaces and folders, which I maybe I will split those three into separate file, maybe this whole thing into separate file, but I still want to have one file per lesson. In my opinion, it's more beginner friendly to navigate. Like, if you want to know what interface section we had, you'll expand this. Inheritance, you'll expand this. Composition over inheritance, bad, good. I think this is quite easy to understand the points that we were trying to illustrate. Also here, region polymorphism, region through inheritance, and here through interfaces. So sorry for a crappy start, but I think we learned quite a lot. Through inheritance, through interfaces, polymorphism. Inheritance. You're welcome. I will upload to Git and I will share it. I will post it at the end of in the chat and in the channel. Okay, encapsulation. This is actually a part of polymorphism. Polymorphism through inheritance. And we didn't cover abstraction, but we will. We will. Okay. Save and git commit, and I'm done. I need git ignore as well. Let me get that. Git ignore. Paste. Okay. Let's create a lesson. Oh, not new project. New file. And let's call it lesson 1. Now let's have everything that we have here in here. Now this. All the way here. And this will be lesson 1. I'll call it static. Static void main. Instead I'll call run. And this will be private. Okay. And now I just say lesson 1 run. So if I run, it should still work, but it does not because right. I should have put you slightly down. Okay. Now if I run, it still works, so all good. So all that you need is here, with all the remarks I made. Alright, so let's go back and do the commit. Lesson 1. Inheritance, encapsulation, inheritance, polymorphism. And if I go to OP lessons, if I refresh code, and if I go here, lesson 1. Okay, I will post homework tomorrow. So thanks all for watching and see you next time. Bye bye.